I'll try to explain what that means. So who am I? I'm Sharad. I'm a first-year CSEC student here. I like kernel shit. I like reverse engineering as well. There's my Discord, and there's my GitHub. Okay, so why is it called GhostFops, and what is it? So GhostFops is a kernel module that's intended to perform virtual file operations. What I mean by that is that these file operations are considered virtual because they do not persist through restart and they're not logged. But the issue is that it's in the kernel, so that kind of sucks. Okay. So as an intro, what is the Linux kernel? So the kernel is put most simply, is a piece of software that manages the resources on a computer. So it manages hardware, it manages stuff like the timer, it manages the disk, it manages all the devices that are plugged in, it manages the CPU. The kernel really is the puppet master of the computer. A program will only run on a system if the kernel wants it to run. And that's really why the kernel is so powerful. If you're familiar with the Intel architecture, you might be familiar with ring 0 versus ring 3. Kernel is considered to be ring 0 because it's closest to the hardware. Okay, by the way, this is actually a pretty complex topic, so I'm really just gonna go over the details. If you wanna know exactly what goes into this, go to the GitHub. There's a big README that describes exactly what this project is doing and how it accomplishes it. So the dirty bit, what is it? So in memory, we have something called paging. That's how we manage memory. In memory, the data structure that represents the page, the PTE, has a specific bit called the dirty bit. The dirty bit represents whenever that region of memory has been written to. So whenever that region has been written to, that dirty bit gets flicked on by the CPU. And it's important to know that dirty bit, that specific dirty bit, is set by the CPU. It's set by hardware. The software, the kernel, has to do nothing to set that. So now we come to the PG dirty. That's Linux, the Linux kernel's own personal dirty bit. So within the Linux kernel, there's a thing called the struct page. So in addition to the PTE data structure that the CPU has, there's also the struct page, which is the kernel's page management data structure. It contains a lot more information, which makes it a lot more useful for the kernel. So the important thing to know about this dirty bit, it functions almost the same way as the PTE dirty bit, but the thing to know about this dirty bit is that it's set by software. It has to be set manually by code, by software. So there are actually cases where the PTE's dirty bit is set, but the kernel's dirty bit is not. This desynchronization is really what I exploit here. Okay. So the page cache. The page cache really is the subject of this exploit. It's what's exploited. So I'm going to get into that, explain briefly what it is. So disks are shit. If you've ever worked with hardware stuff, you know that disks are extremely slow compared to memory. So while memory access might be a few nanoseconds, disk access is like a few milliseconds or even microseconds. So because disks are slow, we store copies of files in memory in something called the page cache. So because of the speed of memory, all file operations are performed on the page cache and then synced to the disk later. So for example, if you read a file, that file will be, instead of being read directly from the disk, it'll be read from the page cache in memory. So because the files are copied into memory, we can modify memory to modify the files because the files are in memory. That's kind of the idea. So this module exploits how write and mmap work. I'm only going to explain how write works because I'm not sure how many people here in this room are familiar with mmap. So yeah, let me explain how write works. So write works in a pretty simple way. When you call write, it writes the buffer that you're trying to write to the page cache and sets that page that was written to dirty. So at the point the page is set dirty, it's not immediately written back to the disk. It's instead, the kernel really just waits and decides when it wants to write back to the disk. So there are a few cases where that can happen. You either call sync, which is one of the syscalls or commands, or the kernel is running out of memory, and then it'll flush those pages back to the disk. The critical issue here is that the dirty bit within the struct page is set by code. So if we never set that dirty bit, that buffer, the page that we wrote to from the kernel, will never be written back to the disk. So in that sense, we can create virtual file operations. I don't know if that made sense, but yeah. OK. I think demonstration, yeah. Okay, wait. There we go. Okay, so yeah, time to show what this does. Let me make sure everything's configured properly. Okay, this is not actually a comment. This is for later. So I'm going to show 3 demonstrations of like increasing complexity to show what this does. So what this does is we have this file called test file here. It just has a bunch of like hello worlds in it, and you have the Q there. So what this first test is going to do is it's going to modify that Q to an A, and I will show how that test is really how it really is like temporary. So okay. So let me make this real fast. Ooh, okay. So, oh my God, it's an A. So yeah, that's so. As you can see, we modify it to an A. Very cool. Okay, so now I'm going to show how these file operations are temporary. So I'm going to type a command that drops the page cache here. So this command drops the page cache, and it drops the page cache as well. It syncs all the dirty pages. So as of right now, the page that contains this file is not dirty. So the kernel has no incentive to write it back. So if I type this command and go to open test file, there's a Q there. So and this will also work on restart. If I restart the computer, if I restart this VM, the Q will be there instead of the A. So this is not the only thing you can do with it. You can also have quite a bit of fun with it. So one thing that I did last night was I essentially blocked root authentication. So you can't do. So if you literally just change the first letter in shadow, you'll straight up block root authentication. So that's pretty fun. Okay. Oh no, it's still in there. Okay, so if I see shadow, go up here, you'll see that the root, so what it used to be root is now an A. Okay, so what does this do? So if I do sudo cat etc shadow, I type in my password. Wait, what? That's interesting. That did not happen. That's interesting, actually. Okay. Oh, wait, no. Oh, wait, there we go. Yeah. Those, oh, wait, shit. Oh, okay, yeah, those are all there's my password hash. Have fun hashing it. I don't really give a shit. Okay, anyway, so as you can see, when I tried to, it was sudo su. So I can't authenticate into root anymore at all. So that's one like really, really basic fun thing you can do with it. So I'll try to show a more complex example. So here I have a copy of libc. Actually, let me drop the page cache first. So yeah, there's the page cache. I'll show you that the page cache is indeed dumped. So should be an R. Yeah, it's an R there. So I'll try to show a more complex example. So the complex example that I'm going to show off is, so I have a copy of libc here. So I'm going to change write to, oh wait, what? Why is it still here? Okay, well, oh that's why. I forgot to close things. This is the most scuffed presentation I've ever given in my entire life. Okay,
Is it even truly a demo of things actually work correctly?
Huh?
Is it even truly a demo of things don't all?
Yeah, true. I was showing it to another guy here, and yeah, I forgot to close a bunch of things. So let me dump the page cache again. Okay, so let me make sure this is actually working. Okay, yeah, so this is the original code for write. So I'm not going to explain what this code does. It's a little bit complicated, but this essentially just calls the syscall for write. So what I'm going to do is I'm going to give a theoretical example. I'm not going to run it because it'll crash Linux. I don't really want to do that. Instead of writing what the buffer actually is, I'm going to write like the buffer trolled just for fun. Just like the word trolled in place of every buffer. So I'm going to show you how to do that. So Okay, let me uncomment, recomment some things. Yeah, so this code there's a lot of code here. So here are all the opcodes that I'll be writing, and here's a string that I'll be writing. So you'll see what this, I'm not really going to explain what okay, let's make this again. Let me exit. Okay, yes, go. Oh. Nice, okay. And it didn't work. What is it doing? Oh, right, that's what I forgot to do. Change the file. Yeah, okay. What the? I've never seen that happen before. What is going on?
You need to do rmod ghost.code.
What?
Rmod ghost. Oh, that shouldn't matter.
No, that shouldn't matter. That would remove it. What? I've never seen this before. Wow. This?
Do resets or
What have I done? Okay. Well, okay, I accidentally solved the problem that I wanted to solve for yesterday. I just broke write. So this is actually write breaking. So what this is actually doing is this is writing. So, oh my God. Well, that's like a really convenient time for this to happen, actually. Holy shit. Okay. Yeah, so what's happening is that, so the way bash works, is the way at least this is the way I presume it works, is that bash is writing everything. So when you type something, when you type a command, I guess, it'll write it onto the screen. It'll use the write syscall. So I essentially, so instead of replacing with trolled, I replaced it with this string, which is, this string is actually part of libc. So that's really cool, actually, that I managed to do that. So basically, this is a much more destructive example of what you can do with this. I don't know how to reset this, so I guess I just have to reset. So I guess I just have to restart because I don't really have it. I can't really type anything now. Okay. Wait.
unless you manage to break that by.
Okay. Well, nice. I managed to break literally everything apparently. Yeah.
That's a sign you've done something very cool.
Yeah. Okay. Wait. Okay. I need to test this. Okay. Okay. This is new for me as well, so we're gonna have some fun with this. Okay. So if I write this and save, what happens? Oh wait, I can't even cat anything. I'm trolling. I can't even. Oh my God. Okay, wait. Okay, let's see if a TTY or. I give up. Okay. I tried to use a TTY, and oh my God. Okay. Yeah, basically it crashed. Okay, so as you saw, I just managed to. I don't really know why that worked, but basically I broke write. So, and if I restart this machine, I'll show you that it still works. It should still work properly.
Broke, right?
I broke. Yeah. Oh man. Oh right. Yeah.
It's like you broke the important thing, like make it work some machine for it.
Yes, I broke
Why'd you do this?
because it was fun. Anyway. Yeah. So that's cool. Let's restart it. What? I mean, I have to replicate it though. I don't know how to I don't know what I did for that to work.
Also, ISPS is a professional red team, not the RIT red team.
That was very fun. It should be fun.
Well, you had a good demonstration, though.
It was kind of fun. You know, this is new.